So the last chapter, okay, the last chapter would be Numpy, right? Numerical Python. Numpy represents numerical Python. Okay, so for numerical Python, of course, first thing you install Numpy package, then you just see what is your version. Okay, so Numpy very close to matrix. In fact, the purpose of Numpy is to represent matrix. So you have a lot of functions where you can just directly call and use. For example, shape, size, the dimension, and the type. Okay. Now, example of Numpy array. Okay, Numpy array, somewhat similar. You see, just now earlier we used only bracket, but now we use Numpy np.array. So we are creating array. Previously, you just put a bracket is enough to create a list. Now it's a function. So using a function array to create a matrix. This is a matrix. This is a two-dimensional matrix actually. Again, you see two bracket, two bracket. So it's a two-dimensional bracket, two-dimensional matrix. Okay. Now this is the first row, second row, third row. Two-dimensional matrix. Yeah. Confused already? Yes. You may have how to differentiate. Huh? How to differentiate? This is a two-dimensional matrix, I say. How? Hmm? Just now we understand x and y easy, right? Now this how? What? I cannot say x, y, z. Right, it's still three-dimensional, isn't it? How to differentiate? Why is this two-dimensional array? Yeah? For what? It's like this actually. Surface. A surface is two-dimensional. A surface is a two-dimensional object. A one line is one-dimensional object. A point can be two-dimensional or one dimension or even three-dimensional point, right? And this is actually a surface. A surface is two-dimensional object. If you cut a line, you get a point. Intersection is a point. You cut a surface, the intersection is a line. Okay. You cut a piece of cake, there'll be two pieces of cake, which is a volume. That is a four-dimensional space. So if I take this one layer, I put another layer on top, then it will be three-dimensional space. And then if three-dimensional space, it will be three. So the easiest is to look at in front. Closing. This is two-dimensional space. I have three-dimensional space. So for three, I'll add one, comma, add another one here, three-dimensional space. Huh? For example, let me create a three-dimensional space. I'll copy this whole thing. You see, this is a three-dimensional space. This is now layer cake already. This is the first layer and the second layer. Okay, dimension 3. So now dimension 3, how many? You see? Oh, sorry, here, the closing here.
So we add another one. Is it still 3?
Still 3D. This is another element. This is the first row. You can think of it first row, first layer, second layer cake, then third layer, but one cake. Right. If you want to make now fourth dimension, it will be another one. All together in this one piece. Huh? Confused already? This is geometry and topology. The dimension is not easy. Okay? But normally, right? Let me go back. Okay, normally we usually have this sort of table in let's say in Excel file. So column 1, column 2, column 3. I have attribute 1, attribute 2, attribute 3. For example, student marks mathematics, student marks biology, student marks chemistry, and then student 1, student 2, student 3, right? So that is just like a table. Symmetric is just like a table. So two-dimensional space is really that we deal with, right? Okay, unless you have a volume data, then it's going to be three-dimensional space. Okay? Normally two dimension, one dimension. And this data is also can be represented in data frame. Usually we play with data frame to, just like for example just now population was two-dimensional data set also. Okay. Now to extract is the same way to extract actually. Huh? The first same way to extract row 0, when index 0 represents row 1. Okay, row 1, column row 0, row 1, column 2. Of course, start with 0. So on and so forth. See, we run this, yeah, for this. So row 1, yeah. And then from here, this row, once I extract this row, I want to extract just number 8 here, the last column. Oh, sorry, the one middle. Okay. So first this row, the first row, and then after the first row, column number 2, which is column 1 is 0, column 2 is 1. Then the same thing, row 3, column 3, right? Because it starts from 0. Okay. And then finally, what does that mean? So basically the first one is row, right? First one is row, second one is column. So when I put double dot means everything, column 2. Okay. See everything in column 2, 8, 10, 12. Can you see? Okay. Okay. Oh, okay. All right. Just to access. Okay, now we are doing previously for list we use range to create number line actually. Similarly, you can create number line with numpy. We use range space, actually linear space. It's actually number line. 0 to 2 pi with 50 elements. Right, 0 to 2 pi. Oh, sorry. Is it what? 50? No, no. Is it 50? Why the rest I cannot see? Why I broke it, huh? I broke it. But let's print X so that you get to see. Print X, okay. I'll print X. Oh. Okay. Oops. Oh. So this is the X actually. Yeah, I printed X. Earlier I didn't print. So 0 to 2 pi with 50 elements between. So it will break 0 to 2 pi into 50 pieces, 50 elements. So this is what you get. Okay. Whereas this one here, remember, fifth element onwards. Right. Fifth element onwards. 5. I always get confused. Huh? Okay. Let me show that also. Huh? Just paste it here. Fifth element onwards. So the first 5 will be missing, right? For example, 0, 0 0.12, 0 0.25 until the fifth, the first 4 elements will go missing. Okay, so 0, 0 0.12 all missing already. Whereas this is everything until 5. Form already. Huh? Need to go back, huh? All right. And here we are again, I think this is the same thing in the how it's all. Right? Two-dimensional space, and then this printing of the matrix, and then printing the shape. The shape, of course, will be 3 by 3. What else? The type of the matrix. The type here we will see Numpy array. Why, of course, we use array np.array to develop, right? You see now, this course is, I mean, this lecture is just creating, right? Creating. We are not doing any kind of operation yet. We have numerical, just one chapter on numerical operation. Then we have one chapter on symbolic computation also. Okay, then we have 2 topics on plotting all this. Okay, there are also a lot of functions to create matrices, 0 matrices, 1 matrices, identity matrices, diagonal matrices, yeah, identity 4. So, of course, you see rank 4, 4 times 4. Yeah, this is identity matrices 4, right? And then here, this is a sequence, and then you're taking this sequence and making it as a diagonal, yeah, np.diagonal. So you get a diagonal matrix where the sequence now is increment of 5, 0, 5, 10, 15. And first we make the sequence, and then we use diagonal and put it in the diagonal. Okay, just for an example, right? And operation. Okay, so operation, a little bit of operation times 2. Now, previously, if you do times 2 for list, it will copy 2 copies of list together. But this time around, this is the standard multiplication, element-wise multiplication. Yeah, element-wise multiplication. So times 2, times 2, times 2, times 2. Oh. Okay, so you have two matrix, which is actually a row matrix times 2 element-wise times, right? So element-wise times means, so 1 times 25, 35 times 1, 40 times 4. So that is element-wise. Okay, it is not the matrix multiplication, not dot. This is element-wise. Still, yeah, in element-wise. Okay. So of course, if you do mp dot square root of v2, it's again element-wise. Element-wise. Okay. So those are the answers. The next one here, Now we want to differentiate element wise and also dot product. So for dot product, we have actually a function called np dot. See the difference. So this one, element wise, each element by element, right? This one is dot product. This is the metric that we usually do to solve linear system equation and all that. Okay. Okay, so there are also as a built-in functions. So for example, sum. Oh, very nice, huh? We can just get the total sum. And then we can do by axis. For example, you want to add the rows. Huh? And then you want to add by column. You can do that. For example, axis 0. Axis 0, it's sum along column. Column. First is column. There's the axis 0 and axis 1. One is sum along column, the other one is sum along. Okay, so one axis 0, sum along column. You put axis 1, sum along row. Okay, what it means? For example, this plus this, going around 2 plus 80, 82, that is by row. 80 plus 8 by column. Okay, so you can control that by stating the axis. Axis 0 for column, axis 1 is for row. So we get a nice value. For example, this is the matrix. The matrix 1 plus 4 plus 7 by column, right? So we get 12. Okay, whereas row, which one is row? Oh, I put mean also. I made it to mean somehow. Okay, that's really confusing. Okay, I shouldn't do that. Okay. Okay, so sum along first row, 1 plus 2 plus 3 is 6. Of course, divide by there are 3, what we get 2. Huh? This one is the mean. 1 plus 2 plus 3 is 6. We have 3 elements. 6 divided by 3 is, okay. Shouldn't do that maybe. Okay, so now creating matrix. Here we are extracting a part of it based on a given condition. Right, so I'm creating 11 element from 0 to 1. After that, I want to figure out in there, in this, so-called this array, those elements bigger than 0.5, right? And then I'm filtering the array and creating a new array. So first is the original 0 to, of course, I write 11, right? So I have 11 elements, and then I am filtering it out. So the filters, as you can see, is either yes or no only. So I get true and false and all that. When I extract in there, I extract the A matrix based on the condition. I get to extract those elements out. Again, a very compressed way, right? If you want to do, you can do using a for loop, or a while loop, right? This is a compressed way of doing it. That's the beauty of the array, actually. Okay, here, creating Sinja is happy, good. So that I think his problem is solved. here we are reshaping. Sometimes we want to reshape in a different format. For example, actually here I'm just creating array like that. So how many? 6, 1, 2, 3, 4, 5, 6, right? So I want to make this into 3, put this below, right? 2 by 3, right? 2, 1, 2, and 3 elements. So reshape 2 by 3. I get a nice matrix. It's a different way of creating matrix. So I get that matrix. Yeah, depends on my problem, what I want to create. Sometimes I just create one, as long as the elements is the same. 2 times 3, 2 times 3 is 6. So that's why I created 6 first, and then reshape it. No? Okay, tutorial. What is doing it? Huh? Yeah, okay. Okay. Finish. What happened? I don't know.